Hello, everyone. Oops. Let's try that again. Boot camp. Matter, its properties, changes, and separation. So this particular podcast homework is going to cover physical and chemical properties and changes and separation techniques of mixtures. Okay, so it might seem like a lot, but it's really all belongs together. If we broke this up anymore, they wouldn't stand well by themselves. So you got to keep it together. This is your fourth Google Classroom assignment for homework credit at the end after you finish taking your notes. And so let's get into it. Chemical and physical properties. Simple stuff. Physical property is like a substance that you can observe. Okay, melting point, color, texture. You know, what color is my shirt? Gray. That's a physical property. Good enough. A physical change is a change that does not alter the properties of the substance. Cutting it up or a phase change. Still the same stuff in another form. My shirt's gray. If I cut my shirt into 1,000 pieces, each one of those pieces will still be gray. So cutting my shirt up is a physical change. Chemical properties. These are behaviors that substances adhere to when reacting with other substances. They typically contain that catchphrase, react with, combines with. Okay, so a chemical property is something like, is it combustible? Does it react with water? Will it turn your skin a dark color if it gets on you? Will it cause a burn if you touch it? Chemical properties can only be measured when you're reacting different substances. And the act in the reaction is what you're observing when you're observing a chemical property. A chemical change is one that alters the composition of the substance. By reacting to things, it will change them. Great examples are burning. And if I take the shirt off my back, it's a gray shirt. If I light it on fire, throw it onto a fire, it will no longer be a gray shirt. It will turn into ash. It will burn. It's no longer made out of the gray cotton material that it once was. The point is that the substance, whatever it may be, is something different after that change. It is no longer what it used to be. A bike chain rusts. It's no longer a bike chain. It's a pile of rust. Simple enough. Separating things. There's only a few techniques we're going to go over. Filtration. Draw the picture. It's not that tough. It's a funnel and a beaker with some labels. Okay? This is how a filter funnel works. It separates, in this particular example, sand and water. Why? Well, the sand does not dissolve in water. So it'll go and get stuck in the filter paper. And it's because it's too large. Filter paper has very tiny, tiny, tiny microscopic pores. Sand gets stuck in it, and the water passes through. Another separation technique is evaporation. Definitely you'll do this here. You will take a solution, which is a mixture, in a beaker, and you'll heat it. Why? Well, to separate salt and water, one of them is going to boil, the other is going to not. Salt dissolves in the water, and that's why filtration won't work. So if you salt and water and pass it through a filter, well, the salt carries with the water and goes straight through the filter, through those microscopic pores. But in an evaporation, the water is going to evaporate, salt will not. So in this particular method, the heat boils all the water off, the salt stays behind, leaving you with, indirectly, a separated mixture. This next one's really cool. I love it. I use it to make our distilled water this year. It's called a distillation. It separates two liquids based on boiling point. Okay, this is how you get liquid helium, liquid nitrogen, all those really cold things. They compress them until they're liquids, and then they let them heat up until one of them boils off, and they collect it. Okay, this is how I get distilled water. This is how you get distilled spirits, rubbing alcohol, all that kind of stuff goes through a distillation process. When you heat it, one of the liquids that has the lower boiling point will boil off first. The other one doesn't get hot enough to boil, so it stays behind. It'd be like separating water and oil. Even though there's a layer in between them, the water's going to boil first. It'll evaporate. The oil will be left behind. So we collect that gas. You turn one of the liquids into a gas, and you pass it through a condenser, and it cools down and turns back into a liquid and drips out as the distilled liquid. This other separation technique, maybe we'll get a chance to show you. It's not very easy. Physical separation, like molecule size and magnetism. For chromatography, we separate by molecule size. There's many different types. The one that I might be able to show you is paper or thin layer chromatography. There are many forms. They're going to vary on which property they'll manipulate to separate the components. Another type of separation is magnetism, but it only works with like iron and magnetic elements. So that's about it. Google Classroom. Complete all your notes, page 22 and 23 in your boot camp packet. Then complete the Google Classroom portion of the homework. And be ready to go over about 3 pages in our packet in class. Observe some demonstrations, see how these filtrations work, maybe get your hands on some stuff. Not actually labs, but techniques you'll be needing later on in the year if you're going to be successful. So that's all, folks. Thanks for watching. Short